Hello everyone, my name is Tetsuro Kamura. I'm in charge of maintaining the university's IT infrastructure at the Art Media Center. Besides, I am involved in digitalization projects such as historical documents, photos, artworks, and instrument concert in our institution. Let me show you the outline of today's presentation. 1. Introduction. 2. Generate basis data and relationship indicators. 3. Cluster analysis of Japanese oil painters network. 4. Analyze characteristics of well-known Japanese oil painters. 5. Discussion. And 6. Conclusion. Introduction. I'll explain the research background here. Background on global level. Recently, we see a lot of attempts to research and business using art data. In this context, there are various factors and elements behind this study. Especially these 5 points are essential things. 1. The art market has been growing worldwide. 2. Open access is implemented in the art-related field overseas. 3. Developed and using artworks or artist-related authority data in overseas museums. 4. Interdisciplinary research and information services using relevant data of art. 5. Attempt to use diverse open data in the art market. However, we face a lot of issues. First, no usable artist and vocabulary data. Second, insufficient data to purchase decisions and evaluation of artwork. Third, a new method of valuing and evaluating artworks or artists is required using digital data. Fourth, creating new social value is required using various data in the art field. This study objective is as follows. We reveal the importance of reusable data infrastructure development in the art sector by utilizing information technology and distribution methodology. This figure is one of the goals of my study. We think that art information can potentially use data in social, culture, and economic development. For vitalization, it is more useful or organize and use art data. These data should be published, shared, and accumulated instead of managed or protected through a unique method or policy. We think that will be needed art-related information pieces, artists, and variations based on numerical data in the near future. However, Japanese art-related studies haven't been examined in depth yet. We attempt to show examples of data usage based on specific data preparation and analysis. In this manner, we showed that publication and use of art-related data could create new social value. In this study, we assume building a system that can objectively use information owned by all organizations and people involved with arts. This would be able to revitalize the art community. Today's main topics. 1. Characteristics analysis using Japanese oil painters, attribute information and web data. 2. Reveal a reality of Japanese artist valuation amount uses as one of the evaluation indicators. 3. Clarify highly related artist elements from analysis data. In this section, I'll show how to generate raw data and related indicators for analysis. Generate raw data. When we analyze something, we need a large amount of data. So, I tried to search for the Japanese artist authority data in Japan. However, I was unable to find it. Precisely, we didn't have usable digital data. Therefore, I decided to use printing books information. Like these books are sold in several publishers in Japan. By the way, I tried to asking the publisher, could you provide digital data to use for research purposes? The answer is no. We had no choice. Hence, we manually input and generate data from 2 Japanese art yearbooks. The following tables shows artist information in the books. After input and generate data, we integrated different evaluation values in the 2 books. In this slide, I explain an artist assessment system in Japan. We have a system known as the GO system. This system can know the rough price of the artwork. We have 0 to 500 Japanese sizes standards for paintings. Most art associations or galleries evaluate a size 1 price to the artist. They are using a masterpiece per the size 1. For example, artist Tanaka has a 10,000 yen evaluation price. If Tanaka created artwork of size 5, that price is an estimated 50,000 yen. Compare evaluation price and age between 2 books. As you can see the table, the left one is describing age groups in the books. You can see there are a lot of older artists, 60 to 90 and 100 years old. And the right one is showing the evaluation price. Most artists are under 10,000 yen, or over $500,000 yen. These ranges are too few. Next, extract well-known artists. To extract well-known artists from art yearbooks, we use the result of art auction data scraped from one of the Japanese auction company website. And then we generated text data after text matching with the artist name. We were able to extract 248 names from auction data. After that, we defined that these names are famous artists in the marketplace. Then, we have created a set of relationship indicators to analyze 248 artist relations. The method is as follows. Search a combination of each artist's names using the Bing search engine. We use the search result as a relationship indicator between artists. In this case, Fujiwara and Yamada's relationship indicator values is 62. Other components. Also, we use some components for artist variation from web services. Product Museum Project, Getty URL Link Open Data, DBpedia Japanese, and Wikidata. We took the number of occurrences of an artist's name used Sparkle API. I'd like to move on to the next topic, cluster analysis of Japanese oil painters network. In this section, we will explain clustering and community detection in artist networks. Please look at the table. The artist network using for analysis is an undirected graph with 248 nodes and 7,163 total edges. Nodes use attribute data such as evaluation prices, association, address, and school. Edges use related indicators. Evaluation price and Japanese oil painters network. We classified the artist network into 5 groups using the Levine algorithm. The node size indicates between a centrality and colors are a group. We can see that a large node is an important person in the artist network. I will explain in more detail each group. Characteristics of Cluster A. Cluster A has 19 nodes and 597 edges. It is the most number of nodes among the 5. The number of edges and the average degree are smaller than others. A graph density value is the lowest, as you can see from the table. Its value is 0.149. Therefore, these clusters artists are less in communication with each other. Cluster B. Cluster B has 59 nodes and 807 edges. It is the highest number of edges among the 5. It has a high value of the average degree and the highest median evaluation price. It shows that this cluster is actively communicating with each other. Cluster C. This cluster of artists are widely scattered. This point is also unique. One of the reasons is 28 of 44 artists' affiliations are independent or unknown. Other clusters are almost all artists belong to some associations. Therefore, the impact of every one of them is evident in the graph. Cluster D. Cluster D's edges and degree are high value. the highest graph density of the file. A dense activity each other. The highest median evaluation price. This value is same as cluster B. Cluster E. This cluster nodes, edges, and degrees are the lowest of all, and it locates far from center of the Japanese oil painters network in here. However, it has the highest average evaluation price. There are 3 and 4 million yen artists in the cluster. In this section, we revealed elements of the evaluation price and built a model explaining characteristics. The construction of the model used 17 variables, including the numbers obtained in the analysis. We classified 17 variables into 6 categories: artworks, personal connections, relationship indicators, web search, academic components, and personal data. This table shows a model of evaluation price. We created characteristics of well-known artist model using multiple regressions analysis. As a result, we obtained 13 different variables and a 0.7 adjusted coefficient of determinations. It seems to be a lot of auction volume variables. Relationships between the measured and predict values of evaluation price of artists. This figure is a fitting of the predict and measured values. As you can see from the graph, higher evaluation values tend to have higher variability. We need to make some improvement in the model expression. This slide shows the most influential factors to evaluation price. We extracted variables that have a significant impact on the coefficient of determination and measured their importance. As a result, we can see extracted 7 important elements: auction price, auction volume, alma maters, associations, degree, Google search, and age. Discussion. Now, we have summarized it into 3 points to consider the relationship with famous artists and reputation. What are the factors that make evaluation price increase? First, a large number of artworks widely distributed in the market. This meaning is artistic activities are likely to be active. In short, there are ongoing production and trading. This meaning is someone makes provenance, execution history, and artist information. And so, biographies, reliability, and supporting information of value are on record. It is advantageous to have a lot of artworks distribution. Second, can search for artists and artworks information on the web. If a lot of information on the web, such as an art auction, exhibition, galleries, and weblog, so on, information is distributing for some purposes. They are possibly leading to improved product reputation, and value. Third, have multiple to connect with artists, alma maters, and associations. Have a lot of different connections, such as various schools, art groups, and persons. That helps to get inspired by other disciplines, cultures, and thoughts. It is considered that a lot of artistic activities and experience are factors of increasing value and reputation. The result of this analysis is possible to predict artists likely to increase evaluation value in the future. So, the development and the utilization of various art-related data will be able to create new social value. In this way, it is possible to recommend buying an artwork, provide trend forecasting and trend analysis for the art community. We believe that artist introductions and trend analysis using machine learning will be possible when using various art-related data on the web. On the other hand, the slide shows a regional trend of Japanese oil painters in Japan. This figure analyzes using national tax audit and population data, plus this study's data. We can propose art and town development to the local administration if we can use more detailed artist and open government data. And one more slide. Where is the most artistic activities city in Japan? This figure shows the oil painters' population inflow and outflow by prefecture. Tokyo is center of artistic activity in Japan. On the other hand, Kanagawa Prefecture is the most popular residence. The top 5 popular cities in Kanagawa is follows: Yokohama cities, Kamakura, Sagamihara, Kawasaki, Fujisawa. By combining different data, we can find new discoveries. Conclusion: we clarified that art-related data have the potential to be used for a variety of applications and their usefulness. We indicated a need for concrete measures to improve the art data infrastructures to vitalize Japan's art community. Significantly, development of following data are most important to the art sector: Japanese art thesaurus or vocabulary, Japanese artist authority data, open or publish artworks by usable data. In this study, we created a lot of data manually. We hope it will be easy to use near future. Thank you for your attention.